We're still looking at fractals, okay? This is only our second go at it. I gave you some far more complicated fractals to build, ones that were just impractical to do on your own. Now, with Raphael's help, I put together this one. Do you recognize it? We gave this a name last time. What's it called? This is Sierpinski's triangle, right? Now, what's interesting is that it didn't start with a triangle at all. Last time you built it like this. I think you had your triangle, and then you did an upside down triangle in that, and then you did upside down triangles in those, and off you went from there, okay? But this shape here, right, started completely differently, which is what these boys are doing over here. It started with a trapezium, okay? I'll very quickly show you the first couple of steps and you can see maybe how it grew up, right? I've got 3 equal sides on this trapezium, and I use those 3 equal sides as the base to form new trapezia, okay? So for example, I've got a new trapezium down here, which is similar to the first one. I've got a new one up here, which is also similar to the first one, so these two are congruent. And then I've got one in here, okay? And then I've got more trapezia to repeat the process, and that's how this thing built, okay? So you can see that particularly as I build these ones on top, that's what gives you that sort of triangular shape, right? But Sierpinski comes back and invites us again, even though we started with trapezium shapes, okay? So therefore, this idea of fractals and how they're constructed, here's the important idea. Everything you've all been doing today, it's a process, it's called iteration. This is a massively important idea that you need to get down. Okay? Iteration. Iteration is it's a noun in a couple of different ways. It can mean a process, or it means the results you get from the process. This word, iterate, means, as you've been able to tell today, you take some idea, some procedure, and you do it over and over again. Okay? So for example, it was the construction of those trapeze. Oh, that's terrible. Sorry. More and more trapeziums over and over again. And this shape emerges, okay? Or you had your triangle, a lot of them start with triangles, right? And then what you were doing was called barycentric subdivision, because you found what's called the barycenter, okay? You divide it up through angle bisection, right? Then you do a few more lines by angle bisection at the middle, and now you've got 6 triangles that you could do barycentric subdivision again, right? So for example, over here, it'll look something like this. Then you divide up those, and now you've got 6 more triangles, and on and on and on. Okay, so iteration is a repeated, or here's another word for you, or recursive process. Right? You're doing the same process to increasingly smaller subsets of this picture. We're doing it geometrically. So what happens is, we're going to move next lesson from geometry, right? We're not going to completely go away from geometry, but we're going to think about it instead of draw this and then bisect that, okay? We're going to introduce this idea of iterated function systems, okay? Even if you've never seen the language before, you know what functions are. Functions are things like x squared or the square root of x minus 1. These are things that you put a number in, an input, x, right? And out comes something else, some other value. This is a function, right? And we're going to do them over and over again and see what happens with different kinds of functions.